a comparison of a Turing machine with a von Neumann machine. In this study, we'll explore two pivotal models in the history of computer science, the Turing machine and the von Neumann machine. Understanding the differences and similarities between these two architectures is crucial for grasping the underlying principles of how computers work. This comparison will be particularly useful for learners in the field of computing fundamentals. Two pillars of computing. The world of computing is built upon theoretical models and practical implementations. The Turing machine represents the former, an abstract, theoretical model of computation. The von Neumann machine, on the other hand, is a practical architecture that forms the basis of most computers we use today. While seemingly disparate, understanding both is essential for a comprehensive understanding of computing fundamentals. What is a Turing machine? The Turing machine, conceived by Alan Turing in 1936, is a theoretical model of computation designed to explore the limits of what can be computed. It consists of the following components. An infinite tape, divided into cells. Each cell can hold a single symbol from a finite alphabet. A head, this reads and writes symbols on the tape and can move left or right. A finite state machine. This dictates the machine's behavior based on the current state and the symbol read from the tape. The state machine follows a set of rules that determine the next state, the symbol to write, and the direction to move the head. The Turing machine operates by reading the symbol under the head, consulting its state machine, and then performing the following actions. Write a new symbol on the tape. Move the head either left or right. Transition to a new state. The Turing machine's simplicity is its strength. It serves as a powerful tool for proving the computability of algorithms and understanding the theoretical limits of computation. Any problem that can be solved by an algorithm can, in theory, be solved by a Turing machine. What is a von Neumann machine? The von Neumann machine, named after mathematician John von Neumann, is a computer architecture based on the stored program concept. This architecture, which underpins most modern computers, is characterized by a central processing unit. This executes instructions. It comprises the arithmetic logic unit and the control unit. Memory stores both instructions and data. Input-output devices allow the computer to interact with the external world. A single address space, instructions and data reside in the same memory space, allowing the CPU to access them using a single address. This is a key feature of the von Neumann machine. The von Neumann machine operates by fetching instructions from memory, decoding them, and then executing them. Data is also fetched from memory and processed by the CPU. The results are then stored back into memory or sent to output devices. A comparison of a Turing machine with a von Neumann machine. Key differences. Now, let's delve into a detailed comparison of a Turing machine with a von Neumann machine. Key differences explained. Theoretical versus practical. The Turing machine is a theoretical construct, while the von Neumann machine is a physical architecture. Memory. The Turing machine has infinite memory, whereas the von Neumann machine has finite memory. This is a fundamental limitation of real-world computers. Program storage. In a Turing machine, the program is encoded in the state transition function. In a von Neumann machine, the program is stored in memory alongside the data. This allows for greater flexibility and programmability. Instruction set. The Turing machine has a very limited instruction set, while the von Neumann machine has a rich instruction set that allows for more complex operations. Complexity. The Turing machine is conceptually simple, while the von Neumann machine is significantly more complex. A comparison of a Turing machine with a von Neumann machine. Similarities. Despite their differences, there are also some important similarities between a Turing machine and a von Neumann machine. Both are computational models. Both models are capable of performing computations. Both process information sequentially. Both models process information one step at a time. Both rely on a set of instructions, Both models operate based on a set of instructions that dictate their behavior. Both have a concept of state. Both models have a concept of state that changes as they execute instructions. The von Neumann bottleneck. One significant limitation of the von Neumann machine is the von Neumann bottleneck. This refers to the limited bandwidth between the CPU and memory. Because instructions and data share the same memory space, the CPU can only fetch one at a time. This bottleneck limits the speed of computation. The Turing machine, with its infinite tape and direct access, doesn't suffer from this limitation in its theoretical form. In conclusion, the comparison of a Turing machine with a von Neumann machine highlights the evolution from theoretical models to practical architectures in computing. The Turing machine provides a fundamental understanding of computability, while the von Neumann machine provides the basis for most computers we use today. Understanding the strengths and limitations of each model is crucial for anyone studying computing fundamentals. While the von Neumann machine has its limitations, ongoing research and development continually seek to overcome these, building upon the foundational principles laid out by both models. Further reading and scholarly sources include Turing, A.M. on computable numbers, with an application to the Entscheidungsproblem. Proceedings of the London Mathematical Society, 42, 230-265. Von Neumann, J. First draft of the report on the EDVAC. Moore School of Electrical Engineering, University of Pennsylvania. Goldstein, H. and von Neumann, J. Planning and Coding of Problems for an Electronic Computing Instrument.